Sorry. That's great. Hey, we're here. We're going to change a defective GFI outlet. Really, the first thing you need to do is, well, this one's actually working fine, but we're going to demonstrate its defectiveness. I wanted to show you this GFI tester. They're $10 or $12. They're not too expensive. They do an actual overload test on them that allows you to be sure that the GFI is working properly. Just by pushing this button, you'll pop it, you'll lose power. All you have to do is reset it. You should be good to go. If you have to follow the color code on top to make sure that the proper lights are lit so that you don't have an open ground or something of that nature. If a GFI outlet has an open ground or hot neutral reverse, it won't pop effectively anyways, so you already know something is wrong. If for some reason you're having a problem with the outlet, it's popping very easily. Over time, the springs in there can wear out and they'll get to where they'll pop with just the slightest bit of issue. And sometimes all it takes is to put in a new GFI outlet and kind of take care of the problem. So we're going to do that real quick. It really just takes a few seconds. The first thing you need to do is turn the power off, but really the best way, not yet, but when we're ready, I'm going to do something special to make it turn off apparently. This device here is probably the easiest way to make sure you find the right circuit breaker. And you just plug it in here, you'll see a light come on. That tells you it's receiving power. This obviously doesn't work on outlets that are defective for some reason. But if you're having problems finding your circuit breaker, these tools work in combination. They send a signal to each other to help you find the right breaker so you don't have to turn off the power to the whole house. So they're great that way. This is a volt tick. If you've watched any of the other electrical things, you know how important this can be. This tells us if there's power so that we know not to play with it until there isn't power there. And the other things I have with me are some basic hand tools for electrical work. And I've got the Wiring Simplified book available as a resource if I ever need to check anything on it. Okay, we're going to start by removing the cover, which is pretty simple. Standard bladed screwdriver, 2 small screws, which can get loose and crazy and be hard to find later. So pay attention to where they are and if they fall, where they fall. Like that one right there. I don't know where it went. We'll find it. Now, at this point, by now you definitely need to make sure the power is off. I'm going to turn the power off by going like this. Look at that, no light. We're going to double check it with this tester. No lights, we're good to go. It's ready to work. Okay, now what we need, don't plug it back in. That would be bad. We're just going to loosen up the 2 Phillips head screws that go here. You can obviously use a power tool of some sort to unscrew these quicker if you'd like. I try and avoid that because you don't want to get them too tight. A lot of the times, like this box is a plastic box, so the threaded hole that this screw is going into is plastic, and we don't want it to get stripped out and not be able to hold the plug accordingly. Now once you've got those 2 screws loose, you can spin the outlet around. You've got a view of what's happening. You've got a green grounding screw. You've got a gold hot incoming. It's off the black wire. And you've got a white screw that's for the neutral. These outlets up here, or these places up here to tie in wires are for if you are going to piggyback multiple outlets onto this GFI. Any outlets that were hooked onto this line output area would be GFI protected through this outlet. I think you can do up to a total of 6 outlets, but you'd want to check the book to make sure. In the meantime, you never want to get those reversed. You don't want your incoming power going into these underneath the tape because the GFI breaker will not work effectively. Okay, so all we're going to do now is basically unscrew these. Almost lost that screw, so let me set that down before it goes crazy. These use a clamp type system to hold the wire, so it's really as simple as loosening that screw. Each of the screws are the same way. We'll get this one loose, ground will be out. One more for the neutral. All 3 of those are out. Now, we're making sure those wires are in good shape. There's no visible cracks or damage to the wire itself. Usually, sometimes you can find a small ring up near the insulation that would signify the potential for a break in the future. It means it got over squeezed, if you will, when they were stripping off the insulation. So keep an eye out for that. Otherwise, you just need to make sure that the wires go back to their proper location on the new one. The neutral goes to the silver screw. Also, it's labeled on the back of the outlet. It says white wire, and right there it says hot wire, which in our case is black. In most cases is black. And then the green is for ground, of course. We're going to seat those wires in as far as they will go and then tighten their appropriate screws. A little bit of a tug to make sure it's okay, doesn't hurt as well. And we'll get the hot wire in next. All the way down. Tighten the screw. Now, we're going to fold the wires kind of like they were. You'll notice they're kind of folded up to take up space. We'll get this outlet pushed back in. Get its screws set. We should be ready for power on and a good test. If I could get my wall to sit still, that'd be great. Once these screws are in, you don't want to get them too tight because it will fold these plates that the screws run through. Just enough to stop side-to-side motion of the outlet to hold it solidly in place. You'll know when you can't wiggle it anymore. Then you're just going to put the cover back on. I'll worry about that screw I dropped a little later. And now you can always turn the power back on and test it before putting the cover back on. That's no problem. If you're concerned whether or not it might have taken care of your problem. But at this point, we'd want to turn the power back on like that. Now, will it mechanically trip? Yep, that part works great. Power's back on. Now let's see if, looks like our hot and neutral are in the right places and there's no open ground according to the light diagram on the top. We'll test it that way and make sure it's working effectively that way as well. Looks like it's good to go. Now I'm going to go find that other screw so I can get on with my day because I've got other things to do too.